So this is my my crude artwork about trying to put this grand sweep of history into perspective, with starting with the arrival of the Maori in the past 1,000 years, and well, actually, I don't think the video is actually running anyway, but it's a combination of 60-year tradition with Antarctic operations, and just recently the launching capability to launch to orbit, and then a future of opening up for us with the of Moon, Mars, and asteroids. And I think one thing that's excited me about considering this big future potential is that it really makes all of history alive. You're suddenly going back and saying, what exactly did they take on these sailing vessels? How did they survive in these environments and things like that? And so, at all scales, it's like everything, all of all of global history becomes a prelude to the future that we're about to embark on, and the future is coming much faster than I think you may realize. That some of these proposals, this is me trying to connect the Maori history to a future of these vehicles, because these vehicles are arriving in about 10 years, which will be 100-person class vehicles to the Moon and Mars. And so suddenly it'll be something that we're sort of been put to sleep by the traditions of big billion-dollar shuttle flights and things like that. And suddenly the idea that ordinary people can be involved in exploration into the solar system is going to be coming very quickly. So that's all context for when we approached Christchurch, NZ, about creating a space challenge, and discussing different ideas about what the challenge might be. They wanted to focus on and build on the tradition for the Antarctic exploration. And so there's so many analogies between Antarctica and future space exploration, and there's also so many things that current technologies and space technologies could help with Antarctica. And so that's how we, first off, we're trying to avoid this kind of situation, which is crossing Antarctica. There's dangers of crevasses all over the place. And this is from 1959 Trans-Antarctic expedition, the UK and New Zealand traversed. And somehow they say that they got this vehicle off the crevasse. I don't know how they did it. Sideways, I guess, or something. But they also lost another vehicle, and that was actually the first New Zealander lost in Antarctica. He plunged into the crevasse. But I also like this image because this was chosen as to represent the challenges of exploration, and was put on the Voyager record, and so it's now going out of the solar system as one of the representatives of Earth. And recently we have our friend and EHF fellow Dan Price conducted a traverse on the Ross Ice Shelf, which is really, he's going out to set up a drilling site. It's really critical for measuring for the climate, understanding the past climate for the past million years, and also the current situation is when accelerating. And so it was 6 weeks on the ice, traversing the Ross Ice Shelf, and it's the Ross Ice Shelf is much larger than the North Island, so it's a real big traverse, and so it's absolutely critical for the climate of the whole globe, and so. But in order to traverse it, you have to avoid the crevasse fields, and they're here they are planning for months about trying to find a safe path using whatever available data they have. And
if you used to point it towards me, it might.
yeah, okay.
You should shoot me.
Just happy with the laser.
Yeah.
Okay, so this is the statement with the challenge we have. Using new or current technologies or data in space or on the ice, find the best methods to identify hazards on the map and map a path across the ice. And the second part is design or prototype new sensor systems or algorithms to help vehicles navigate across the ice in Antarctica. And so one part is to go from remote sensing data from satellites and to find a safe path, and the other part is the sensors on the vehicle, or they can either be inside a human crew vehicle, or it could be robotic vehicles. And so, and the prize for this is $40,000 to be awarded in May. So we have a lot of different technologies that and skills that people could apply to this. If you're, some people are interested in analyzing the satellite data, seeing what they could do to help identify the path that way. Some people are experts at different kinds of sensors, or interested in drones or things like that, and there are some crazy ideas that we've heard as we're in our tour that I don't know if they're going to work. I don't know if people understand the Antarctic conditions really, but they're going to make great movies if they. And so we're focusing it on this challenge that also applies immediately to other extreme environments. And our interest is, we think that it's going to be immediately applicable to the Moon and Mars and other worlds. And then there's also commercial applications for, and so we're trying to encourage people to create solutions that could become businesses, could be, they would keep the intellectual property and be getting a lot of support for the finalists to incubate their ideas and develop and market their ideas to, especially to, one of our partners is the Committee for National Antarctic Programs. So there's 30 countries that have Antarctic programs, and they want to highlight whatever we can come up with to the rest of the world. So one part of this is understanding the data analysis of things like the synthetic aperture radar that sees through the clouds, it sees through the polar night, and you can just barely see the crevasse fields here. And you can, I don't know if you can tell, but DAM's route was threading its way through the crevasses, and they went 50 kilometers out of their way in order to just avoid this area right here. And then we have, let's see, okay, yeah, so while Dan is driving, he's looking at the satellite data here, and then he's looking at data from the ground penetrating radar here. And you have like little clues that there might be a crevasse or some kind of thing right in front. And so you only have a few seconds if you get a warning before you have to stop driving, or else you'll plunge into the crevasse. And so I just can't imagine a worse combination of boredom and terror. As if you're sitting there 8 hours a day looking at this whole thing, and you have a 4-second warning, you can see a vertical line. It's just terrible. But you also get a clue if the boom suddenly fall into the hole. So some of the people in Greenland, they tried testing a little rover, zigzagging back and forth, to see if that would help. But Dan, whenever he saw some kind of vertical line, he would go out and poke it to see how strong the ice bridge was, just to see if it was strong enough to drive across. And then they were able to fly a drone sometimes, but a lot of conditions they weren't able to fly a drone, of course. So this is the general criteria. The details are on the website and the application form, but basically it's finding a technical solution, innovative solution, with factors for ease of implementation, there's factors for team composition. There's a preference for prototypes or proof of concept if you can get a sensor actually working, but it's also open to just general ideas about different approaches, and we're giving it a lot of freedom to the judges to sort out what they think is an interesting idea to bring forward.
So it's just ideas, you don't need to have
Yeah,
proof.
That's right. Yeah, yeah. A working proof might, trump an idea, but just an idea. Some of the wild ideas were, especially from the movie industry, they had some crazy. So we're trying to collect resources as much as possible, reports and what's needed, data sources, even some sample code for analyzing some of the data, web links, and we're using a number of different channels to collect this. We're also organizing training sessions on, for example, open source geographic information system analysis software that used to cost $50,000 and is now free to download. So that's part of the transformation that we're promoting. And we are setting up in parallel our portal, our community portal, so that people can say that they're interested in part of this and find teams and find groups that they can work with. This is where we're also collecting information about just companies that are working in something space related and providing opportunities for people.
Yeah, so I'll go back and talk about the mechanics of the challenge. So we kicked it off like February 1st, and anybody can either submit between now and April 30th. And so they got about like 3 months time frame to kind of like work on it. But it's also two-tiered, which means that there's like 5 regions of which, so for example, the region where Northlands is part of the Northlands, Auckland, and Bay of Plenty like region. And essentially the applicants will apply in region and they will be evaluated in region by regional judges. By the 16th of May, those regional judges will pick a finalist for each of the region, and those finalists will come then to Christchurch during Tech Week on May 24th to pitch, and then we will award kind of like the grand prize winner. So the application requirement is it's actually very simple. We have an application platform, so everything is just like uploaded into this platform called Slidero. And maybe just to point out really the 2 things here that they should be working on is a 20-slide presentation pitch deck, and it's also very open and flexible. We're not like saying what's on that deck. It just depending on the judging criteria that you just saw, that's sort of like their guideline for what they should be putting on their slide there. And then the other is a video of potentially if you've got a prototype or you can actually explain it more visually. We're asking them for a 5-minute video. So those are really the 2 things that they need to submit. And then just to elaborate more on the prize, as Eric mentioned, the grand prize winner will get $40,000, sorry, New Zealand dollars. And also some technical and research support as well from Callahan Innovation. All of the finalists will also get sort of like in-kind support, incubation and mentorship support for at least 6 months after the challenge. I think actually this is, for me, the most important because it helps those teams to work on their ideas and their projects like, after the challenge and make them potentially businesses in the future. And then also the then also each of those finalists will be given travel expenses covered for one person to represent that team to actually pitch during the Tech Week in Christchurch. And then all throughout the time period, there's going to be mentoring as well that is given by Calhan Innovation and GQ Law, which is specialized in basically space law here in New Zealand. And again, the community portal that we're kind of like developing is all for the applicants. Even if you don't finish or even if you don't finalize your application, what we're trying to do is creating a community within New Zealand who's really interested in space and making those connections for people to connect and find those people that they would want to work on, even if they don't join the challenge. So this is my last slide. So how can you get involved? As Jivine was like saying before, I think it would really be great if you knew of anybody or if you knew of organizations or teams that could potentially work on the challenge. We're hoping that you come out of here becoming cheerleaders of the challenge and essentially spread the word. And as mentioned, there's a lot more information online. The New Zealand Space Challenge.com website has the FAQs, so it's more extensive on if there's questions on there. And if you have any questions, please feel free to email applications at NewZealandSpaceChallenge.com as well. The space portal that Eric was talking about, we are currently, it's a little bit buggy right now, and we're still also developing it, but at least the resources section, also we keep on adding information there. We just did a training in Auckland, as Eric was mentioning, on geographic information systems, and we'll put the video on there and also the materials that came out of it also in that resources area. And we started a YouTube channel as well, where we've been kind of like taking the videos and putting those on the channel so that it could be shared for those people who could not attend the briefing. And so I will end there. We've been so grateful to all of our partners. This is essentially, not all of them are here, but we would not have done this without the support of all of the regions within New Zealand, and hoping that you would also support us by promoting the challenge. I think we'll kind of like end there.
Yeah, please.
There is that one short video if we want to.
So yeah, we could actually do the
Dan's video.
video. It just gives a little bit more understanding of the challenge itself, and then.
That's it.
Is this the video?
Yeah.
It is.
But it needs audio.
Sound, so give me one. Why are you thinking of questions? Because that's the next section we're going into.
Well, if you have
Sound guys buying yourself some time.
Yes.
Do you have LiDAR messing on Antarctica?
Well,
There is
yeah.
some, and there's also a new NASA satellite that's just launched, or actually, it's just launched. They're doing preparation for LiDAR mapping. But yeah, it's not as extensive as they want. So, yeah. But that's the actually very precise.
Yeah.
Point.
I recently last summer took part in the first major traverse New Zealand has mounted across the Antarctic since Hillary did it in the 1950s. The amount of planning that goes into the traverse is pretty incredible. So it's a 2-year planning phase with the logistics that happens, and then I was involved about 6 months before using satellite imagery to plan the whole route. Of course, Hillary and all his boys didn't have any of that, so we've got this amazing satellite resource that we can use to get imagery of the road going and sort of locate all the hazards, and the major hazards are crevasses. So the whole objective is not to drive into one of the crevasses, and these satellites really provide an amazing tool to do that. We also have a radar mounted on the front of the first vehicle, which is an incredible tool because it gives us about a 4 or 5 second warning if a crevasse is coming up ahead of us. So one of us is driving in that vehicle and the other one is continuously monitoring that GPR, ground penetrating radar system, and then we get a really good idea of what's coming up ahead. All we're trying to do is prove a route so that the science can be done at specific sites. And there is thought in the future that we might use the actual traverse route to do some science too, so drag instruments with us and kind of have a sort of circus of scientific instrumentation and tour in Antarctica.